working on a problem having to do with curve sketching. We are asked to consider f of x equals x minus 1 squared times x squared minus 16 and g of x equals x squared minus x minus 2 over x plus 1. In this video, we will be looking at f of x. The first thing that we are going to do is determine if there are any discontinuities. Since this is a polynomial, there are no discontinuities or limitations. We next look at the intercepts. For x equals 0, we have that f at 0 is negative 16, and we see that f of x is 0 precisely when x is equal to 1 or plus minus 4. We now look at any asymptotes. Once again, since this is a polynomial, there are none. Let us now look at critical points. Expanding f of x, we receive the following, and thus getting that f prime of x is f of x cubed minus 6x squared minus 30x plus 32. Setting this to 0 and factoring, we get x minus 1 times 4x squared minus 2x minus 32. We then factor out the 2, and we see that our critical points take place at x equals 1 and x equals 1 plus minus root 129 over 4. We had to use our quadratic formula because our term was unfactorable. Let us now look at potential points of inflection, and we do this by looking at f double prime of x. So we find the derivative of f prime of x. We obtain that our second derivative is 12x squared minus 12x minus 30. Factoring out the 6, we get 6 times 6x squared minus 6x minus 5, which is also unfactorable, and so we use our quadratic formula to obtain that x is equal to 3 plus minus root 39 over 6. We now create a table with all of our intervals, critical points, and potential points of inflection. On our left-hand side, we have f double prime of x, f prime of x, and f of x, and we also note the places where either our second derivative or first derivative are 0. Let us recall our first and second derivatives. We will first look at the second derivative and see where it is positive or negative, and we do so by substituting values within our respective intervals into the second derivative to see whether we obtain a positive or a negative value. Our second derivative is positive from negative infinity to 1 minus root 29 over 4, at 1 minus root 29 over 4, and in the interval of 1 minus root 29 over 4 to 3 minus root 39 over 6. But it is negative in the interval of 3 minus root 39 over 6 to 1, at 1, and also from 1 to 3 plus root 39 over 6. Looking at our final interval, we see that the second derivative is positive in our final 3 columns as well. Now looking at our first derivative, in our leftmost interval it is negative, in our next interval it is positive, as well as at 3 minus root 39 over 6, and from 3 minus root 39 over 6 to 1. We see that the first derivative is negative in our next 3 columns, and in our final interval, we see that it is positive. In our row for f of x, our original function, we draw our curve by looking at the first derivative and the second derivative. By doing so, we will be able to determine the shape of our graph at more detailed points. This particular function isn't the easiest to draw in a detailed way. This is a rough estimate of how our graph will look like. We see that we do have the graph having a W shape, and if you go on Desmos.com, you can input f of x and it will show you its graph, and you will see the various different areas where you have your points of inflection and your critical points. For instance, here you can drag to see where exactly a certain point lies. For the second part to this question, please look at our next video. And for more information concerning curve sketching, please refer to our library guides.